So in this video, we're going to take a look at the point-to-point protocol and touch on the HDLC protocol as well. We talked about some of the problems with HDLC in the sense that each vendor has its own proprietary implementation of how HDLC should really work when we get to that third layer. So if we have two devices that are different vendors, we have to do point-to-point protocol or something different than HDLC. Now, PPP is a data link layer protocol, so just like what we saw with the HDLC, but what it also adds in there is some different stuff, like our LCP, that link control protocol, which helps us build and actually initiate that connection between two devices. And then lastly, the part that's pretty neat is NCP, the network control protocol, which allows the two devices to negotiate which layer 3 protocols should we allow to pass across this link. If you want to map it out to the OSI layer, HDLC and PPP don't do anything unique really on layer 1. Layer 2, HDLC lives in and kind of leaves layer 3 up to however that router's manufacturer decided. But with PPP, we have the LCP, which initializes a connection between two routers, and then that third layer, that blue layer up on top, layer 3, the NCP, which actually says, here's what we're going to use as far as protocols go operating at the network layer. LCP also helps us with a couple of other things. So we can do authentication with PAP or CHAP. We can compress our data, so getting a little bit more bandwidth, or freeing up some bandwidth, I should say. Does some error detection, make sure that that link is loop free. We can do multi-link, which means we can have basically different physical paths represented as one logical path. So for example, if you took two T1 lines, LCP would show them up as a one line of 3 megabits per second. And then PPP callback, which is where the client will call to the remote server, which is your ISP. Once the authentication and everything goes through, the ISP will hang up and then call the client back, which is something really nice for billing and getting accurate, real usage out of how is this link being used. So it goes through 3 different phases here. So we have our link establishment, that's our LCP. LCP figures out, do we need to do any authentication? Is there anything else unique that we need to set up? That'll be the next phase if it's actually needed. And then lastly, like we saw before, the NCP tells us basically what network protocols are going to be encapsulated and sent over this PPP link. So let's talk about authentication real quick. If we're going to set this up here, 2 different ways we can do it. We can do it with PAP, which is a little bit older, less secure. The passwords are sent in clear text, and they're only exchanged once. So, it happens on the connection initialization. It doesn't ever get checked periodically throughout the connection. We have CHAP, which is a little bit better. So not only does it get checked every time that connection is established, but also periodically throughout the connection time. The devices are not sending these in clear text, so it's basically just using an MD5 hash of the passwords. It's not the ideal, most bulletproof solution, but certainly better than clear text. So we can actually go through configuring PPP on these devices. It's pretty simple. Basically just change our encapsulation type to PPP. After that, we can go set up some host names, set up the usernames for them, and then configure authentication on it as well. So let's flip over to Packet Tracer, and we can just walk through this real quick. What I have set up here is 2 routers, R1 and R2, and they're connected with a 172.16.10.0/24 network. You can see here the little clock next to my serial interface represents the DCE connection, which means my router 2 will be operating on the DTE side of that serial interface. If we wanted to verify this here, I'll just open up my router, get to enable mode, and do show interfaces serial 000. And basically what we can see in here is we're using HDLC. So looking through my list to find it, there we go, encapsulation HDLC. So we actually didn't have to configure anything, it's just by default. And if I do show controllers, serial 000, there we can see on my DCE device, my clock rate is 2 million. Let's change this over to use PPP authentication. what I'm going to do is I'm going to go into config T. We're going to go into our interface serial 000, and I'm just going to set the encapsulation. So we have 3 modes in packet tracer. We're going to set this to PPP, just to see how this looks a little bit differently. Now what you'll notice right away is when I did that, since we have different types of encapsulation on the 2 devices, my line protocol went down on that serial interface. If I get out of this and just go back up to show interface serial 000, what I basically see is encapsulation is PPP now. LCP is closed, meaning it wasn't able to actually set up a connection on both ends. And this is all of the NCP protocols that are not coming across anymore. If I go over to router 2, and let's just do this real quick. Let's go into config T. Oops. If we do a shift 6, control shift 6, get out of that. Config T, interface serial 000. Let's do encapsulation, PPP. As soon as we hit this, the line protocol should come back up. And there we have it. Now if I do a show interfaces serial 000, what we see here, LCP is open, meaning that connection was actually established. And here's our NCP protocols that are going to be encapsulated over the PPP line. So very cool stuff there. Now, one of the other advantages of PPP is that we can do authentication between these 2 devices. Let's talk about that a little bit. In order for this to work, we have to have a host name set on each router. The host name of the remote router is going to become a local username on this router. So for example, if I go into config T, I'm going to create a username. I create the user account for my remote router. In this case, it's R1. Password, and I'll go with something simple like Cisco. We're going to do the same thing on the router 1 here. So let's do it over here. So config T, username, this time it'll be router 2, password of Cisco. And those passwords should match on each of the routers there. Next thing that I need to do is go to my serial interfaces, so int serial 000, and set it up for PPP authentication. And this time I'm going to choose CHAP. If I wanted to do a fallback, I could also specify PAP like this, but I'm just going to do CHAP. Do the same thing over here on router 2. So go to interface serial 000, PPP, authentication, CHAP. And there we have it. Our line protocols are back to up. Now we should be able to see this if I do an end here, and I can do a debug PPP authentication. As soon as this tries to re-authenticate here, and this happens periodically, we would see a bunch of basically successful authentication messages. I'm going to turn it off for now, and we'll just test it just to make sure it's working. So do an undebug all, and let's just try to ping this other router, 172.16.10.2. Now something very interesting with PPP, you can actually have mismatched IP addresses, and by the way PPP works, it'll actually set this up in our routing table for us. So what this is going to look like is, let's just change the IP address on one of these routers, and we can just test with it. So IP address something that really doesn't exist, but router 1 should still be able to ping it. Interesting, right? These 2 devices have completely different subnets, but they can still talk. If you do show IP route, we'll do this on both here. What we're going to see in the routing table PPP has actually put the neighbor's IP address as a static route in here, or a direct connection. So, by the nature of it, these two routers can still communicate. Now, it's not ideal, because this is not going to be really effective for anything besides these two routers communicating, but something I found interesting. This should come from the CDP traffic. We're going to do our show CDP neighbors. Basically, it's pulling the IP address from that router over CDP, placing it into the routing table. That's all we've got for PPP for now. We'll pick it back up again with frame relay.